All right, on this first one, in order to rewrite this rational function in this form, I need to actually do the division. So I need to synthetically divide. That means, up in my box, I'm going to put the value that makes whatever I'm dividing by equal to 0. That would be positive 4. And then I'm going to list out my coefficients. So 1, negative 12, and 27. First step is to bring that first value straight down and then multiply by what's up in my box, add straight down, multiply by what's in my box, add straight down, and that final value is my remainder. Since I started with a second degree equation and I divided out a linear term, that means my result is going down 1 degree. This would be the coefficients on a first degree equation. So this would be 1x minus 8. And then the way that I would write my remainder would just be plus that remainder of negative 5 over what I divided by, over x minus 4. Since this is plus a negative, I could also just write this as minus 5 over x minus 4. All right, on number 2, we are given our function already in the form of what we just did on number 1. We have our quotient and our remainder. So this tells me my asymptotes. This piece of information right here, the quotient, tells me what I'm approaching to the left and to the right. So I can say in this case my horizontal asymptote is y equals 3. And then whatever I was dividing by tells me my vertical asymptote. Now, we're thinking in this case what value of x makes this denominator equal to 0. So in this case that would be positive 5. So I would say my vertical asymptote is at x equals positive 5. So the graph that has those two characteristics is A, right? A horizontal asymptote at y equals 3 and a vertical asymptote at x equals 5. Number 3, story problem. We are getting charged $85 for a store to set up their printing machine for posters, and then 45 cents in materials per poster printed. So, part A, write an equation for the average cost of printing X posters through this company. So, first, let's think about the total cost. So my total cost would be that $85 that it costs just for them to set the machine up, and then plus 45 cents per poster. So if this is per poster, I'm going to multiply that by the number of posters that I'm getting. So that is my total cost. To get the average cost then, I'm just going to divide the total cost by the number of posters. So this would be my equation to represent the average cost per poster. For part B then, I want the average cost per poster if I get 60 posters printed. So I'm just going to take that equation that we just wrote, that function, and plug 60 in for x. So I'm just going to have 85 plus 0.45 times 60, all divided by 60. Now, remember, if we are putting this all into the calculator at once, I need to make sure to put my entire numerator into the calculator in parentheses. So I'm going to do open parenthesis 85 plus 0.45 times 60 and close that entire numerator and then divide by 60. So here is my average cost per poster if I buy 60 posters. And since we're talking about money, I'm going to round that to the nearest cent, to 2 decimal places, so $1.87. All right, part C then. We want to figure out how many posters we should print to have an average cost of $185. To figure this out, I need to take my average cost equation and set that equal to what I want the average cost to be. To solve this then, I'm going to multiply both sides by my denominator of x. Over here, that cancels out these x's, and I'm just left with 85 plus 0.45x, and then over here equals 125x. So now, to solve, I just need to subtract my 0.45x over to the other side. We'll get 85 equals 0.8x, and then divide both sides by 0.8, and 85 divided by 0.8 is 106.25. Now, x represents the number of posters. I can't buy 0.25 of a poster, so we need to round this to the nearest whole number, right? So my final answer is really going to be 107 posters. Okay, I need to round it up because 106 posters would still get me an average cost of over 125. So I need to round this up to 107. The last part, part D, what happens to the price of the posters as the number of posters increases? Well, here we need to think about what the cheapest average cost could be. So if I start buying thousands and thousands and thousands of posters, well, that cost is going to keep decreasing until we approach an average cost of 45 cents per poster, right? If we were to graph this function that we created, we would have a horizontal asymptote at 0.45. So we can say the average cost approaches 45 cents. Number 4, another story problem. So here we are paddling our kayak in the river. So if Claire is paddling in still water, she can go 2.5 miles an hour. But she is going to be going upstream and downstream of a river. Now, it takes her the same amount of time to kayak 17 miles downstream as it does for her to kayak 5 miles upstream. So our goal here is to solve for the speed of the river. To do that, I need to first write expressions for for the amount of time it takes her to go downstream and upstream. So to go downstream, we said, let me write this over here first. Time, we talked about this in class, time is equal to distance divided by rate. So here, if I'm talking about downstream, we know that we can go a distance of 17 miles downstream. Now, my rate, since I'm going downstream, that means that the river is helping me, is aiding me. So the rate that I'm going is 2.5 miles per hour plus however fast the river's going, right? That's my expression for going downstream. Let me move this down just a hair here. So now to go upstream, I want to write a similar expression for the amount of time it takes. So this time, my distance is 5 miles, but this time the river is working against me. So that 2.5 miles an hour I can go in still water, the river, the speed of the river, I'm going to need to subtract from that. So these are my two expressions here for the amount of time for downstream and the amount of time for upstream. Now in this problem, it tells us that these two things take the same amount of time. So if I want to solve for r, I can set these equal to each other and solve for r. Now to do that, I'm going to need to identify my LCD. Right? My LCD is going to be just the collection of every factor that I see in my denominators multiplied together. So in this case, my LCD is just 2.5 plus r times 2.5 minus r. So I'm going to multiply both sides of my equation by those values, or by those expressions. So 2.5 plus r times 2.5 minus r. And then over here, same thing. 2.5 plus r times 2.5 minus r. And the reason that we do that is so we can see what cancels. On the left side here, my 2.5 plus r's are going to cancel, and I'm just going to be left with 17 times 2.5 minus r. On the right side, my 2.5 minus r's cancel, and I'm just left with 5 times 2.5 plus r. Right? Our goal is to eliminate the fractions. So now all I have to do is distribute and solve. So 17 times 2.5 is 42.5 minus 17r equals 5 times 2.5 is 12.5, and then plus 5r. So now get the r's together on one side. So I'll add the 17r over. Subtract the 12.5 over to the other side. And I'll get 30 equals 22r. Finally, divide both sides by 22. And 30 divided by 22 gets me 1.36. Now, we should include our rate, or our units here for this rate. So this would be in miles per hour, right? 1.36 miles per hour is how fast this river is going. Now the rest of the problems, we are just solving these rational equations. So what I want to do first is identify my LCD. I need to collect all of my factors that I see in my denominator, but if there are any duplicates, I only include them once. In this case, though, my factors are entirely different. Now remember, even though we don't see parentheses around my denominators, each of those are one factor. So this is my LCD. Now, my restrictions here, these are the values that x cannot equal. And we get those by thinking about what value of x would make each factor in the LCD equal to 0. So my first factor here, 7 minus x, if I were to set that equal to 0 and solve for x, I would get that x cannot equal 7. Here, if I set 2 plus x equal to 0, and I subtract the 2 over, we get x cannot equal negative 2. So these are my two values that x cannot equal. So now to solve the problem, I'm going to start by multiplying both sides of my equation by my LCD. So times 7 minus x times 2 plus x. Now, the reason we do this is going to eliminate my denominators. On the left side here, I can cancel out my 7 minus x's, and I'm just left with 6 times 2 plus x. On this side, I can cancel out my 2 plus x's, and I'm just left with 4 times 7 minus x. Now, I just need to distribute and solve. So over here, 6 times 2 is 12, 6 times x is 6x, 4 times 7 is 28, 4 times negative x would be negative 4x. And now get my x's together on one side, so I will add my 4x over. Then get my numbers onto the other side, so I'll subtract 12 over. finally divide by 10, and we get x equals 1.6. That is not one of my restrictions, so it looks like that is a good answer. On the next one, same process. I want to identify my LCD, so that is just the collection of all of the factors I see in any denominator, but if there are repeats, I only include them once. So my LCD is going to be x times x minus 6. That means that my restrictions will be 0, right? This first factor is just x, so the value of x that would make that equal to 0 is 0, and then the value of x that would make this factor equal to 0 would be positive 6. Again, if we're getting tripped up on that, we can just take each factor and set it equal to 0 and solve, right? So the first one, we already have 0. For the second one, add the 6 over, and we get 6. So those are the values that we cannot have equal to x. So now I'm going to multiply both sides of my equation by my LCD. That is going to eliminate my fractions. So on this side, my x minus 6's cancel, and I'm just left with 4x. On this side, my x's cancel, and I'm left with x minus 4 times x minus 6. So over here, I'm going to have to multiply these out. I'm going to have to either double distribute or set up a box. Right? I like the box to organize. So x minus 4 times x minus 6. X times x is x squared. X times negative 4, negative 4x. X times negative 6, negative 6x. And negative 6 times negative 4, positive 24. So that means this side of my equation ends up being x squared, and then if I combine these two like terms of negative 6x and negative 4x, that would be negative 10x, and then plus 24. And then I still have this 4x on the left side. So we end up with a quadratic that we're going to have to solve here. To do that, I want to get everything on one side equal to 0. So I will subtract this 4x over to the right side. So I'll get 0 equals x squared minus 14x plus 24. So now we've talked about two methods for solving quadratics. I can try to x factor, or I can use the quadratic formula. Remember, the quadratic formula will work every single time. So if you just want to jump straight to that, you can. But I think it's worth it to check to see if we can factor, because factoring is going to be easier if it works. So in this case, on the top of my x, a times c, 1 times 24 is 24, and then my b value is negative 14. So I'm looking for two numbers that multiply to positive 24 and add to negative 14. First, the signs of these values, if I want them to multiply to a positive but add to a negative, I know they're both going to have to be negative. Now, two numbers that will work, that multiply to 24 and add to negative 14, would be negative 12 and negative 2. At this step, I need to divide by my a value, but my a value is just 1 in this case, so that's not going to change these. I'm still going to have negative 12 and negative 2. So when I set up my factors, x minus 12 and x minus 2, my last step then would be to set each of these equal to 0 individually and solve. So for this one, add the 12 over, and we get x equals 12. For this one, add the 2 over, and we get x equals 2. Both of these are going to be good answers because neither one of them are my restriction. So I get two answers here, 12 and 2. For the next one, same process. My LCD is just going to be the collection of all of the factors in my denominator, but if there are repeats, I would only include that factor once. Then my restrictions, for this first factor, I could not get 0. For my second factor, I could not get 1. And again, I can set each of those individual factors equal to 0 to figure out what restrictions I should have. So I'm going to multiply both sides of my equation by my LCD. On the left side here, my x's cancel, and I'm left with x minus 1 times 2x plus 5. On the right side, my x minus 1's cancel, and I'm just left with 1 times x, which would just be x. So now, just like the last problem, I'm going to have to double distribute. So I'm going to set up my box. I'll have x minus 1 times 2x plus 5. 2x times x would be 2x squared. 2x times negative 1, negative 2x. 5 times x, 5x, and 5 times negative 1, negative 5. So combining all my like terms here, we would get 2x squared. Then these would add to positive 3x minus 5 equals x. I have a quadratic, so I want to get everything on one side equal to 0. So I will subtract my x over. So I will get 2x squared plus 2x minus 5 equals 0. So now, again, two methods. We can either use factoring or quadratic formula. If it works, factoring is going to be easier. So let's check. In the top of my x, a times c, so 2 times negative 5 would be negative 10, and my b value in the bottom of 2. So we're looking for two numbers that multiply to negative 10 and add to 2. I don't think those two numbers exist. All right? So that means that we are going to have to use quadratic formula on this problem. So my a is going to be 2, my b is going to be 2, and my c, negative 5. So I'm going to plug those values into my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I plug these in, the opposite of b, so the opposite of 2 is negative 2, plus or minus the square root of 2 squared minus 4 times a times c all over 2 times a. And then we just want to try to simplify from here. So inside of my square root, 2 squared is 4, and then negative 4 times 2 times negative 5 would be plus 40 all over 4. So I can add those together inside the square root. That would be 44. Now from here, there's two things I want to check. First, is this a perfect square? Is 44 a perfect square? It is not. So the last thing I want to check is if I split this up into two fractions like this, can I reduce the first one? Does negative 2 over 4 reduce? And it does. Negative 2 over 4 would reduce to negative 1/2. Now I cannot reduce the second fraction because that 44 is trapped inside the square root and this 4 is outside of the square root. So these would be my final answers on this problem. On the last one, same process. I want to identify my LCD. So that is just going to be a collection of all of the factors I see in either denominator. But if we have a repeat, I'm not going to include it twice. So in my first denominator, I see x and x minus 1. In my second denominator, I see x plus 1 and x minus 1. But I'm not going to include this x minus 1 again because I already included that in my LCD, right? So my restrictions then, my first restriction, the value of x that would make x equal to 0 is 0. The value of x that would make x minus 1 equal to 0 would be positive 1, and the value of x that would make x plus 1 equal to 0 is negative 1. So I have three restrictions on this problem. So now I want to multiply both sides of my equation by my entire LCD. So on the left side, the x's cancel and the x minus 1's cancel. So I'm left with x plus 1 times x plus 3. And on the right side, the x plus 1's cancel and the x minus 1's cancel. So I'm just left with 8 times x. Just like the last few problems, I'm going to have to multiply these binomials together. So x plus 1 times x plus 3. X times x is x squared. X times 1 is 1x. X times 3 is 3x. And 3 times 1 is 3. So my left side of my equation here ends up being x squared plus, if I combine these like terms, 3x plus x would be 4x plus 3 equals 8x. So again, I've got a quadratic to solve. I want to get everything on one side equal to 0. So I will subtract this 8x over to the other side. So we get x squared minus 4x plus 3 equals 0. It's worth it to check to see if we can factor. So a times c, 1 times 3 is 3, and then my b value is negative 4. So I want two numbers that multiply to positive 3 and add to negative 4. Well, I think negative 1 and negative 3 would work for that. So again, technically I would want to make sure I divide by my a value, but my a value is just 1 in this case. So my factors will end up being x minus 1 and x minus 3. So if I set each of those equal to 0, for this first one, add the 1 over, and we would get x equals 1. For this one, add the 3 over, and we get x equals 3. However, 1 was one of the values we said x could not equal. That means that this is an extraneous solution, and our only answer to this problem is x equals 3.